of quadratic functions. And I think we've the first one, the most basic quadratic. Let's see, function notation. So it will look like that. And we see it's a quadratic because it has x squared and nothing's added to it, so it's as simple as we can get. And we're just going to graph it with an xy table on our Cartesian plane. So if I plug 0 in for x, 0 squared is 0. So y, or f of x, is 0. So that's my first point. If I plug 1 in for x, 1 squared is also 1. So if I go over 1, I go up 1. How about 2? If I plug 2 in for x, I get 2 squared. So f of x, or y, is 4. Over 2, up 1, 2, 3, 4. Alright, now let's try the other side. Let's put in negative 1. If I put in negative 1 for x, I have negative 1 times negative 1, which is, again, positive 1. So if I go left 1, I still go up 1. And plugging in negative 2. If I have negative 2 and I plug it in right there, and by the way, that would look like this, negative 2 squared. So negative 2 squared we know is 4. So if I go back 2, I still go up 4. Well, what this looks like, make sure you don't draw absolute value, it's a different graph. This is a U. It comes in like a round curve. And I kind of missed my point. But that's the idea of this graph. Something like that. So that is a parabola, and that's your most basic parabola. And so whenever you see an x squared, you're looking for this shape. That should probably be like in between those two. But anyway, what we want to do is figure out what happens if we add something, subtract something to x, or to the whole function, like this one. So let's go ahead and add 4 and see what that does. So once again, we'll do an xy plane, and 5 points is thorough enough to draw. As long as you have the vertex and you have 2 on each side, that's plenty to draw a parabola. You could even do it with just 1 on each side, since you know the basic shape. I get 0 squared plus 4 is 4. So over 0, up 1, 2, 3, 4. Now let's put in 1. So 1 squared is 1, and 1 plus 4 is 5. So I go over 1, up 5. Let's do one more. Let's go 2. If I plug in 2, 2 squared is 4, and 4 plus 4 is 8. So I go 8. Now let's go on the other side. Again, plugging in negative 1. Negative 1 squared is 1, and 1 plus 4 is 5. So I can see now that it's repeating on the other side. And negative 2 times negative 2 is 4, plus 4 is also 8. So it's symmetrical, and it always will be symmetrical from your vertex. So not a pointy curve, but a nice round. And so if you're looking at that, what happened from this equation to this equation? Well, we can see that adding 4 moved it up 4. So that was a vertical shift. We say a vertical shift because it moved up or down, and in this case up 4. So let's try, if I ask you to graph this one, x squared subtract 3. You shouldn't even have to do an xy table, because now you know that adding moves it up, and so I bet you could guess that subtracting moves it down. So on my xy plane, I'm going to go down 1, 2, 3. That is my new vertex. Now let's make a pattern to make this simpler. From my vertex, look what I did. I went over 1, up 1, and then over 1 more, up 1, 2, 3. And you do the same on both sides. Over 1, up 1, over 1, up 1, 2, 3. So now, once we know where our vertex is, we can just go over 1, up 1, over, up. So I'm out here at 1. And this is at 2. Same on this side. Over 1, up 1, over 1, up 1, 2, 3. Did I count wrong? Over 1, up 1. Wrong. So, here's my graph. Looks like that. over 1, up 1, over 1, up 1, 2, 3 on both sides. Now, there's a line down the middle, and where each side reflects itself, and that is called the axis of symmetry, and it goes right through the situation. All three of our vertices are on x equals 0. Now, since this is a vertical line, it crosses the x-axis, so we name it with x. We say x equals wherever it hits it, and so it would be 0. That's our axis of symmetry. And they'll ask you axis of symmetry sometimes. Another thing they'll want down, 3. Because of that, subtract 3. This vertex went over 0, up 4, didn't it? This vertex was at 0, 0. So they'll ask you vertex, axis of symmetry, and probably some more, but that's all so far. Another thing they might want you to do is graph something that looks like this. F of x equals x minus 1 squared. Now, it looks a lot like adding or subtracting right there, but you can clearly see the differences. Now we're adding it specifically to x, and then it's squared. Here, I just squared x, and then subtracted or added. But now I'm doing it to x and then squaring it. So let's see how this affects our graph. You might be guessing, my class, what they think that's going to do to our graph, and see if they can guess it right. But let's give it a shot. So if I plug in 0 now for x, 0 subtract 1 is negative 1. Negative 1 squared is 1. So over 0, up 1. Well, that's a little bit different. Alright, now let's put in 1. If I put in 1, look, 1 subtract 1 is 0. 0 squared is 0. Let that over 1, up 0. Now let's keep going that way. Let's put in 2. So if I put in 2, I get 2 subtract 1 is 1, and 1 squared is 1 again. So I go over 2, up 1, and now you might notice that, oh, that must be my vertex, because that's the bottom. So now I must be going up on both sides. But let's make sure. Let's put in, what are we at? 1, 2, 3. So if I put in 3, 3 subtract 1 is 2. 2 squared is 4. So over 1, 2, 3, up 1, 2, 3, 4. Let's go to negative 1. Let's go 1 that direction so we can see. If I put in negative 1 subtract 1 is negative 2. Negative 2 squared is also 4. So negative 1, up 1, 2, 3, 4. And look, we see that symmetrism. What do you call that? We see that it's symmetrical in respect to our vertex. So let me see if I can draw a nice round curve through those points. And if we had to name our axis of symmetry, we know that it goes right through our vertex, and so it's x equals, because it goes through the x-axis, and it's where it hits it. So x is over 1, up 0, isn't it? So looking at this compared to this and this, how did this shift it? Do you all see it? Clearly, it shifted it to the right one, didn't it? Here's our original, and we went right one. So this is what I tell my students to memorize. If you see something in parentheses, you actually shift it the opposite direction. So if it's subtract, you're going to shift it the positive direction. And here's the key. If it's in parentheses with x, you're going to move it along the x-axis, or in other words, horizontal. So this is a horizontal shift, and it goes in the opposite direction. So I'm going to say 1 right. So once again, you should be able to graph this now without even drawing a table, because you should automatically know it's in parentheses with the x, so it's going to shift it left or right horizontally, and because it's the number 2. So if I were drawing this now, I would take my xy plane and I would go left 2. Now that's my vertex. Vertex goes over 1, up 1, on both sides, over 1, up 1, over 1, up 1, and then over 1, up 1, 2, 3. Over 1, up 1, 2, 3. And then I draw my nice rounded curve, not a sharp V, a rounded curve. That is a parabola. If I had to name my axis of symmetry, I know that it crosses the x-axis, so it's x equals, where it crossed it, -2. And I know that my vertex is back to. Now let's try to stretch you a little bit. Let's say I give you this one, y, or you could write f of x, either one. I'm going to do x minus 2. On a test, you can always use a table as a backup, but our hope is that we are good enough that we won't have to. And you'll use these shifts for circles, for parabolas, for hyperbolas in 1050. So you want to learn how to shift a graph and not always have to plug into a table. So I would ask my class, I would say, okay, what does the subtract 2 do? And you would go, oh, well, it's in parentheses with the x, so I know it moves it on the x-axis, and because it's in parentheses, it will go the opposite way. So this will shift it right 2. Now this one is not in parentheses, so it's going to be a vertical shift, and it will do what the sign says. So this one will go up 3. So I'll do that first. I'll go right 2, up 3. And that is my new vertex. From my vertex, I know my typical parabola goes over 1, up 1 on both sides. And then it goes over 1 more, up 1, 2, 3. Over 1 more, up 1, 2, 3. So then I draw my rounded curve through those points. And then if they ask me my axis, and I know my vertex, either from the picture or from those numbers, that I went right. Alright, that is how you graph a parabola. And if you'll learn those ellipses, but here is what they'll do to make it a tinge bit harder. They can give you what is called a vertical stretch or shrink. And that is when, this is still 8.5, that is when you see something like this. Anything, a number, times that x squared. Notice in all of our examples, we just had x squared, didn't we? We had plus and minus things, but we just had x squared. When we don't just have x squared, when we have some number there times x squared, then I'm going to write that vertical stretch by a. Now if it's a fraction, it would be a vertical shrink. So it's a stretch or shrink, and if it were dividing by a, it'd be by 1/8 or 1 over a. So, for example, if I gave you this, f of x equals -3x squared. We'll go back to a table for this one. So, I'm going to go ahead and plug some values in. If I plug in 0 for x, I get 0 squared, which is 0, and 0 times -3 is 0. So look, my vertex didn't move. And we knew that because we don't see any plus or minuses. So our vertex is still 0, 0. But here's where the changes come into effect. If I put a 1 in, 1 squared is 1. 1 times -3 is -3. So now, instead of going over 1, up 1, which we normally do, I'm going to go over 1, down 1, 2, 3. Let's go one more. If I go over 2, 2 squared is 4, and 4 times 3 is -3 is -12. So I go over 2, down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Ugh, I picked a big graph. Okay. So now I know it's symmetrical, so I know this side will do the same. Well, let's just plug in -1 to prove it to us. +1 times -3 is -3. So I see that, okay, clearly it is symmetrical, so I know that next point is symmetrical to that point. Again, it looks really steep, but don't draw it straight. It has to have a curve to it. And so what did that negative 3 do? It didn't shift it up or down. There's our vertex in the same place. But the negative flipped it. It's the first one we've seen upside down, isn't it? And that's what a negative does every single time. If A is negative, it flips it. That's called a vertical reflection. And we can write that. If A is negative, it reflects vertically. Now, normally you go over 1, up 1, but guess what we did? Over 1, instead of going up 1, we did up 1 times negative 3, which was negative 3. Then normally you go over 1, up 3, but we went up 3 times negative 3, which is negative 9. So look, here we go. Over 1, down 1, 2, 3, 4, 5, 6, 7, 8, 9. And there we are. So your rule still works. You have to multiply your normal basic parabola. Remember that your normal basic parabola is over 1, up 1, over 1, up. You go up 1 times A, or negative 3. And then you would normally go up 3. You go 3 times whatever you see it stretched. Alright, so let's do one more. Let's put all of this together. Let's do f of x equals 1/2 x plus 4 squared plus 3. Okay, so first of all, let's take care of our shifts. So if you wanted, you could go to a table and start plotting points, but we know this is a shrink, a vertical shrink by 1/2. We know this is in parentheses with the x, so it's going to move it. We'll do the opposite of the sign. So it's going to go left 4. This one is not in parentheses with the x, so it's going to move it up or down, and it's going to do what the sign says. So it's going to go up 3. This, we know, we're going to vertically multiply by 1/2. So because it's a fraction, it will shrink it. So this is a vertical shrink by 1/2. So now let's see if we can graph this. So we're going to go left 4, left 1, 2, 3, 4. And we're going to go up 3, up 1, 2, 3. There is my new vertex. If they ask me my vertex, I could name it right there from those numbers. I know it goes negative 4. Normally go over 1, up 1. But I'm only going to go over 1, up 1 times 1/2. So I'm only going to go up 1/2. And I do that on both sides. Over 1, up 1/2. So that would be 1. I'll be right here in the middle. Then we normally go over 1, up 1, 2, 3. But we go 3, we only go up 1 1/2 right there in the middle. And we do that on both sides. So I'll put that symmetrical to that right there. That is my parabola. So you can see that multiplying by a fraction makes it wider, and multiplying by a number makes it skinnier. Fractions make it wider. Let's see if we can name our axis of symmetry. We know that it goes through our vertex and that it's a vertical line, so it's x equals negative 1, 2, 3, 4. And what else? We've got our vertex. That's it for them to draw a parabola, and you have to pick the graph. So hopefully, if you do this assignment thoroughly, you'll be able to easily pick the correct graph. Good luck, you guys.